Okay, vectors example. This is involving a parallelogram, which is a similar question is mentioned on your specification, so I thought it'd be a good one to go over. So A has position vector 3, minus 1, 3. B is 1, 1, minus 1. C, 5, 10, 3. And we're told that A, B, C, D is a parallelogram. You don't need to overthink these diagrams. So parallelogram A, B, C, D. You need to be going round A, B, C, D. But in fact, where you start with A and which order you go in doesn't matter. And we want the position vector of D. I'm going to put the origin there. So the thing we want is the vector that takes you from the origin to D. Obviously we don't have that, so this is what we're after. But we can use the fact that going from the origin to D in vectors is the same as doing OA plus AD, and that gives you the resultant. So OD is equal to OA plus AD. Because it's a parallelogram, AD is the same as BC. Oops, sorry. Plus BC. And the vector BC is equal to the position vector of C minus the position vector of B, which is 4, 9, 4. So to get from the origin to D, I'm going along OA plus BC. And that leaves me with 7, 8, 7. If you wanted the coordinates of D, you'd need to write them as coordinates, so just be a little bit careful of the difference between the two. So hopefully that's kind of all makes sense, but you can use the fact this is a parallelogram. So going from A to D is the same as going from B to C in vector terms. That's that one. Second part to this, so we have AX is in the same direction as AB. So I've got an origin, I've got A, I've got B. AX is the same direction as AB, so X is going to be along here somewhere, but we don't know where. But we're told that the length of AX is root 6. You don't really, I think, have to do this with the unit vectors. Instead, AB is equal to, so I'm going to try and find the length of AB. So B is 1, 1, minus 1, minus position vector of A, which is 3, minus 1, 3. And that gives me minus 2, 2, minus 4. So the length of AB is equal to the square root of 4 plus 4 plus 16, which is root 24, which is 2 root 6. And so we want the position vector of x, so we want OX. If modulus of AB is 2 root 6, modulus of AX is root 6, then we've come halfway along here, and now you should be back on familiar territory. So OX is equal to OA plus a half AB. So it's this real idea of travelling along vectors. OA is 3 minus 1, 3, plus a half, lots of minus 2, 2 minus 4, and then 3 minus 1 is 2. Minus 1 plus 1 is 0, and 3 minus 2 is minus 1. So that's your position vector of x.